The goal in these examples is to rationalize the denominator. Before we start, note that there's nothing wrong with having a radical in the denominator. It's not mathematically incorrect. It's not even really bad form. It's just somewhere along the way, historically, a lot of times we just got in the habit of not wanting radicals in the denominator. So we do our best to get rid of them often, and it's a really good way to do a little bit more work with radicals and make sure we deeply understand radicals. So let's try some examples. For a, we have 6 divided by cubed root of 9. And there's a technique to these. First, let's rewrite the denominator. So this is actually 6 over the cubed root of 3 squared, because 9 is 3 squared. Now, in order for this to no longer be a radical, we need to have cubed root of 3 cubed, right? Because then that's just 3. So what are we missing? Okay, what are we missing? Well, we have 3 squared, we want 3 cubed, so we're missing just a single 3, or 3 to the 1. So then we take what we're missing and we multiply by that in both the numerator and the denominator. So I'm going to multiply by cubed root of 3 over cubed root of 3. What that does is it kind of messes up our numerator here. So now we have 6 cubed root of 3 up top, but down below, look what we have now. Cubed root of 3 cubed, but cubed root of 3 cubed is simply 3. So this becomes 6 cubed root of 3 all over 3. Finally, we can cancel right there, leaving us with a 2. So this is 2 cubed root of 3. And that technique to define the goal and then to look at what's missing will work for this entire class of rationalize the denominator problems. Let's try B. We have 5 over rad 27a. First things first, you always want to simplify first. So I'm going to put that in red up here. Always simplify the radicals first. So look, we have 27. Well, 27 is actually 9 times 3, and then 9 comes out of the radical as a 3, because 9 is 3 squared. So we can break this down to 5 over 3 rad 3a. Okay, and now it's really not that bad. We don't even need to go. When it's just a single square root, you don't need to give it much thought. You don't need to go through the goal and the missing. You just say, hey, it's a square root. You multiply it by that same square root on the top and on the bottom. Right? And that works for any square root. So if it's a square root, just go for it. 5 rad 3a over 3, well, rad 3a times rad 3a is 3a. So this simplifies to 5 rad 3a all over 9a. Let's look at C. We have 5 over cubed root of 3y. Alright, let's use our technique again. We have our goal. We want to get rid of this radical in the denominator, so we want to have the cubed root of 3 cubed y cubed, right? Because then these come out of the radical. So we're missing, well, let's see here. We have a single 3 and a single y, so we're missing 3 squared y squared. Alright, so that's what we multiply both the numerator and the denominator by, because really we're just multiplying by 1. That's the idea there. 3 squared y squared over cubed root of 3 squared y squared. Okay, so up top now we have 5 times the cubed root of 3 squared is 9y squared. And then down on the bottom, if we combine everything inside the same radical, we're going to have cubed root of 3 cubed y cubed, which is simply 3y. There we go. And note that our denominator is no longer a radical, so we call that a rationalized denominator. Why do we call it rationalized? Well, because square root of 3 and square root of 2 and things like that are irrational numbers. So when we get rid of the square root down there, they become rational. So we have rationalized the denominator. Let's look at D. We have the 4th root of 1/9. Well, first thing is to break this up, right? This is fourth root of 1 over the fourth root of 9. And the fourth root of 1 is simply 1. So really we're looking at 1 over the fourth root of 9, which I'm going to write as the fourth root of 3 squared. Okay, so what's our goal? In order to get that 3 out of the fourth root, we need to have it as 3 to the fourth. Okay, so what are we missing? We have 3 squared. We want 3 to the fourth. So we are missing an additional 3 squared. So we multiply both the numerator and the denominator by the fourth root of 3 squared. There we go, over the fourth root of 3 squared. Really, we're just multiplying by an enormous 1 here, right? This is just a big, huge 1 that we're multiplying by. All right, when we do that, that gives, well, on the top we have fourth root of 3 squared, so that's fourth root of 9. In the denominator, we'll have the fourth root of 3 to the fourth, which is 3. That's the end of that.